in our understanding of dinosaurs that I've been able to help fill, and now I've written quite a few papers on them, and we're learning more and more every day. And so, armored dinosaurs, their closest dinosaur relatives are the stegosaurs, but they look a little bit different. But what they share are actually those plates that go on the stegosaurus's back. And so these are special bones called osteoderms. So the armor plates on a stegosaur and an ankylosaur are a shared feature between those two groups. Osteoderm basically means skin bone. So these are really weird bones that grow in the skin of those dinosaurs. And we don't really have anything like that in our bodies, but it's something that you see in armadillos and a couple of other animals. And so this is a cool example. So this is a little piece of Komodo dragon skin. That's the outside, that upper area. And then when you flip it over, there's all these little light bones on the inside. So they really grow like right underneath the scales. And so it's found in, osteoderms are found that have sort of independently evolved in certain lizards. They're in armadillos, that's what makes the shell of an armadillo. They're also in things like Gila monsters, all these little like bumps under their beady scales. And crocodiles also have them, so little prickles on the back of crocodiles, and alligators also usually have a little bony core inside them. So I really like armored dinosaurs because I think their spikes are really interesting and have very interesting anatomy. And I've been really lucky because I've gotten to help name 3 of them at this point. And the one that I just named last year, we named Zool after a monster from Ghostbusters. I think you can see the resemblance here. So this is a dinosaur from Montana that's at the Royal Ontario Museum, and before I came here I was working on an exhibit all about Zool and other armored dinosaurs, and that's been really fun. I really enjoyed working on that specimen. I've done a lot of work looking at like how the ornamentation and armor on their heads can be used to tell different species apart, and so I've looked at dozens of specimens like all over the world and trying to figure some of this stuff out. So that's pretty fun. Some of the work that I've done is I look at their anatomy and I collect lots of data, and then I use special like statistical software to help tell what species are related to each other to make those family tree diagrams. So I can look at things like how they evolved and their biogeography, so why we find certain species in certain places, and how they might have moved around and migrated into those spaces. So some of the work that I've done has shown that most of our species in North America are actually immigrants from Asia that then sort of diversified into their own distinct group. So they're basically like their closest relatives are in Mongolia and China. So that's pretty fun. But my favorite part of ankylosaurs are their really cool tails, because they have these really crazy tail clubs. So they have these stiff tails that are tipped with a big blob of bone. And here I'm holding the smallest one that we know of, and standing next to just about the biggest one. So this tail club, this is the knob of the tail club, and it's about 60 centimeters wide. It's really big. It's really crazy to think of an animal carrying something that big a couple meters away from its body.